Assalamu alaikum beauty viewers. The topic of today's video is the generation of the radioactive rays. So in this video I am going to explain how alpha, beta and gamma rays are generated, and secondly I am going to explain the penetration power of each of these. Okay, so first of all what we have here is the definition. So first of all you need to know what is an alpha particle. So an alpha particle, an alpha radiation is actually the radiation that is released from the nucleus, that is released from the nucleus when the nucleus attempts to stabilize itself by emitting an alpha particle. So alpha radiation results when an alpha particle is released from the nucleus. Okay, so what is an alpha particle? An alpha particle is actually a helium nucleus that has 2 protons and 2 neutrons. Okay, so as you can see in the alpha decay, alpha particle is going to release, and alpha particle has an atomic mass of 4 and atomic number of 2. So if I have a general element, say X, that has an atomic mass of A and atomic number of Z, so when an alpha particle is released from this element, the atomic mass is reduced by 4, as you can see A minus 4, and atomic number is reduced by 2, as you can see Z minus 2, and then in result and in product I have an alpha particle here. Okay, as you can see here that if I have a parent nucleus, okay, if I have a parent nucleus, the parent nucleus will convert into a daughter nucleus along with the release of an alpha particle. Okay, so I am going to explain this with an example. So as you can see here, uranium has an atomic mass of 235 and it has an atomic number of 92. So as I have told you earlier that after the release of alpha particle, the atomic mass is reduced by 4 and atomic number is reduced by 2. So as you can see here that 235 becomes 231. Okay, the atomic mass is reduced by 4 and atomic number is reduced by 2. So 92 become 90 and uranium changes to thorium, and the result is I have a helium nucleus. Okay, and this here is an alpha particle. Okay, helium nucleus is known as the alpha particle. Okay, so the next thing what I have is beta radiation. So as you know about the beta radiation are of 2 types. Okay, beta particles are of 2 types, the positive beta particle and the negative beta particle. So negative beta particle is produced when a neutron changes into a proton, when the neutron changes into a proton and an electron. Okay, so this electron that is produced is known as the beta particle. Okay, so I'm going to explain this with a general equation here. So here this is the negative electron. Okay, what I've told you earlier that in the nucleus the neutron converts into a proton along with the release of an electron. So this electron that is released from the nucleus is known as the beta particle. So as you can see here that my neutron is converted into a proton. Okay, my neutron is converted into a proton. So the atomic number should increase by 1. So Z plus 1. Okay, since the number of protons is increased in the product, as I have told you earlier that the neutron has converted to protons, so the number of protons is increased in the product. So increasing the number of protons means the atomic number is increased by plus 1. Okay, so here as you can see the atomic number is increased by plus 1 and I have a negative beta particle. Okay, so I am going to explain this with an example. So here is an example of beta decay. As you can see here that atomic number 92 is increased to 93. Okay, as I have told you earlier that after the release of a beta particle the atomic number is increased by 1. So the atomic number here is increased from 92 to 93 along with the release of this beta particle here. Okay, so this is my example. So going back, this was the example of the release of negative beta particle. So in case when a positive beta particle is released, okay, so what happens in case of a positive beta particle, the transformation of proton into a neutron through the emission of positron. Okay, so what happens when a positive beta particle is released? The proton, okay, the proton converts into a neutron. Okay, the proton converts into a neutron along with the release of a positron. Okay, a positron is similar to an electron but has a positive charge. So as you can see here in the general equation that the positive beta particle has a positive sign. Okay, and since as you know what I've told you earlier that the proton is going to convert into neutron, means now the nucleus will have lesser number of protons, mean the atomic number will decrease. So in this case as you know that a proton is converted into neutron along with the positive positron, so the atomic number is decreased as 1 proton is consumed. Okay, so atomic number is decreased by 1. So here in the product I have Z minus 1 along with the release of the positive beta particle. Okay, so the next thing what I have is the gamma radiation. Gamma radiation is simply a loss of energy by the nucleus. So actually when the nucleus is excited it will release the energy in the form of gamma rays. Okay, so the much like an emission of the light or X-rays by energetic atom. So when an energetic atom releases its energy, it releases its energy in the form of a gamma radiation. Okay, so here is my gamma emission. As you know that the gamma ray does not have any charge and gamma ray does not have any atomic mass or atomic number. So the release of this gamma ray does not affect the nucleus, only it de-excites the parent atom. Okay, as you can see here that my parent atom is excited. Okay, after the release of this gamma ray, the parent atom is de-excited. Okay, the parent atom is now relaxed. Okay, so the next thing I am going to describe is the penetration power. So I have just described you how the alpha, beta positive, beta negative and gamma rays are produced, and now I am going to describe their penetrating power. So first of all, what I have here is the alpha particle, and as you know about alpha particle, that alpha particle is doubly positively charged helium nucleus. So alpha particle is so much heavy, it is so densely charged that even it cannot pass through the paper. Okay, that even the paper can stop it. The next thing I have is beta particle. Okay, the beta particle can be negative beta particle or positive beta particle. Okay, the beta particle can pass through the paper, but it can be stopped by the plastic sheet. Okay, the next thing I have is gamma rays and X-rays, and the gamma rays and the X-rays can pass through the paper, it can pass through the plastic, but it cannot pass through the lead. Okay, the lead will stop the gamma and the X-ray. So if I talk about neutron, as you know that neutron is not charged, the neutron is neutral. The neutron can pass through paper, neutron can pass through plastic, neutron can pass through lead, but the only concrete stops the neutron. Okay, so alpha particle cannot pass through paper, whereas beta particle can pass through paper and reach the plastic, but cannot pass the plastic, and whereas gamma and X-ray can pass the paper, plastic, but cannot pass the lead. So whereas the neutron can pass the paper, can pass the plastic, can pass the lead, but cannot pass the concrete. So that was the penetration power of alpha, beta, gamma and neutron. So that was all for today's video. So in this video I have told you how the alpha, beta and gamma particles are generated and their penetration power. So inshallah see you in the next video. Allah Hafiz. Do not forget to like the video and subscribe this channel.